Thank you very much, Scott, and thank you to the organizers. It's great to be here in Europe for the conference. I'm going to try to put some jokes in the talk, but I'm really bad at telling jokes, so they might not be funny. But so here's our agenda. We're going to get to the talk content in a little while. We'll have a little bit about image update automation. I have a lot of slides, so I'm going to go a little bit fast. And I tried, like I said, I'm bad at jokes. I can't, I asked ChatGPT to help me with a joke, and this is as far as I got. I'm not sure why they're on the wrong side of the bar, but okay, so some more business to take care of, get out of the way. The slides are in Markdown. You can go download them in case this is difficult to follow, in case I'm paging through too fast. But all right, so there's a Flux roadmap, which I'm not going to go into detail about, but we'll call back to later. We'll talk a little bit about the Flux components and Flux 2.6 that's coming any day now. And we're going to start with some of the more unusual resources that you might find in Flux and move on quickly to what a good Flux experience should be like and how to get there, okay? And it's important for me to note at this point that there are different ways to arrive at a good experience. And some of them are better, more situation appropriate than others. So also the meat of this talk is actually about what to do when things go wrong. How do you prevent things from going wrong? So how not to have a bad experience. What are the tricks and tips? Okay, so the setup from the beginning, if you're new to GitOps, I expect most people who are here are not, but perhaps we have some newbies. The experience should be like, in my opinion, you just push to Git and your changes go in, all right? But obviously there's a little bit more to it than that under the hood. And sometimes you're waiting. And that's actually what this talk is about primarily. So there's two options to fix that waiting issue, okay? In my opinion, there are two options. There are probably more than two, but there's the minimal way to solve this, and then there's the tricked out way. And we're going to focus on the tricked out way, okay? This is a word I like. It's called, you can see what it means, ricing. All right, so we're not really talking about ricing out your GitOps cluster. It's configuration that you have to do for production. And you can get away with not doing it. And I'm talking about these things because I think probably most people are not doing these things unless they're very serious and in a big company where they're centers of excellence or that types of thing. Okay, so how do you know if your change went into the cluster? Well, you can run flux git customizations. You might see the change there. You can run flux get sources git. If you didn't see it, you might see it here. You can go download a UI if none of those are clear. And if you have reached this point and you're still not sure if your change went in, you're probably giving up at this point, okay? But don't give up, don't despair. Use notifications. I've heard repeated throughout the talk so far this morning, observability is not optional. I agree strongly with this. You need to set up notifications. You need to do it soon. If you don't have this, you're going to have a bad experience, okay? You want instant feedback when you push your change. It's not in the GitOps definition, but I think it's a core part of GitOps. I think it's essential. If you don't have instant feedback, you're going to have a bad experience. You need to know right away when something went wrong or when something goes right. Right? It's the feedback loop. You want it to be short. The key here is instant. Okay? Delays impose cognitive overhead. I've heard that expression used already too. Thank you, Andy, for using this word. Okay? So GitOps is based on polling. And I think polling is kind of wasteful because most of those polls don't actually pull any change. They just check and there's no change, right? So there are places where you want fairly tight interval. 10 minutes is the default interval in most places in Flux. And if your interval for your customization and your Git repo are different, you might have different experiences. How do I set these? What should they be? My advice is start by leaving them at the default and then make adjustments from there. But don't make any adjustments until you have set up receivers. We'll get to receivers in a second here, because if you thought polling was wasteful before, try polling by hand, right? Flux get customization leads to burnout. Overload, all that stuff is bad, right? Flux reconcile, also an anti-pattern. You should just be pushing and your change goes. I've heard a lot about Argo UIs and adoption over time, and start with the push only mode where someone is in the loop and they have to click. I think that's great, but it's not the end state that you want to get to. Those things help you get there, and I think that's great. But those delays, those context switches, going to the UI, all that stuff is extra cognitive overhead that takes you out of your terminal, and you lose track of what you were doing, okay? So I'm going to try to keep the pace up here. Notifications and receivers help developers, right? So start with alerts. We all need a little bit of help. I'm not going to cover how to set up alerts. There's already a talk about that you can follow, and there's great documentation. Do set up alerts. That's message number one for this talk. If you take away one thing, set up alerts. Get notified where you are. There are 20 plus supported alert providers in Flux, okay? If you can't find one that works for you, come talk to us. We'll help you figure it out. So shortened feedback loops. This is a key idea in DevOps. Notifications and receivers help developers to iterate quickly with no extra steps. Okay? This is how you get a good developer experience. You want the joyful experience. You want to avoid RSI and pain. Those are things that you shouldn't have in your daily workflow if you can possibly avoid it. And receivers part of alerts are also part of GA in Flux. So, all right, so you've got two options, like we said. Number one, if you don't care about performance, maybe you're running Flux in kind or on your laptop, those are great. And you probably won't set up alerts or receivers. And I think that's fine. But this is not how you should do it in production or in any permanent environment, okay, that devs are actively using, because they're going to have a bad experience and they're going to blame you who set it up. Or they'll blame us. So don't blame us, okay? We said we have lots of options for you. And and if you don't care about performance, but you do care about speed, this is kind of a contradiction, isn't it? Well, no, not really. I mean, you can always sacrifice these things to avoid configuration hassle, and that's a win, right? If you can avoid the configuration hassle, that's great, okay? But in production, in the cloud, those things do have a cost, and it adds up quickly. And if you have an audit environment, you want to do it right, okay? You shouldn't be polling every 20 seconds or every 5 minutes, because every one of those things generates an audit log, and those audit logs cost something, and the bandwidth costs. Okay, so let's do some Flux examples here. What's a problem that Flux solves that you might not be familiar with? YAML goes stale. So when you write an image tag into your YAML, how does it get updated? There are lots of ways. You could do it manually. I suggest you might not want to do it manually, especially if you're trying to iterate quickly. And you have a lot of repos to track. Some of them don't belong to you. Some of them do belong to you. So there's different strategies, but you can use image update automation in pretty much all of the situations that I'm aware of. Okay, so how does image update automation work? Well, we've got this image policy marker that tells Flux what image policy to use and where to put the new tag when it comes. So this is really easy. We want to see, what does that image policy look like, right? It's another resource kind. Flux is based on single resources that do a single responsibility. So the image policy's job is to select the latest image using a policy that you define. So 0.x here. So if we go back, we can see 0.x matches the image that we're using, and we will avoid upgrading automatically to 1.0 in case there's a breaking change in there. That's usually what that means when the first number changes, right? So here's an image repository. And if you'll go back and look at this image policy, we refer to the image repository with an image repo ref here. So the name is the same. And there's the image repo to scan. And image repository is mirroring tag list. So it will go and check if there's a new tag every 30 minutes, and it's just going to keep a local list of tags with agnostic of what policies might be in place. Okay, so 30 minutes is a great starting point for a remote repo that you don't own. But if you're doing active development, that's actually way too long. And I think 10 minutes is too long, and 5 minutes is probably too long. And actually 2 minutes might even be too long, right? But polling has its limits. So how do we get around this? Well, we're not going to set the interval to 10 seconds unless we're doing a live demo and we don't care about performance. We're doing this on our laptop. It's actually absolutely fine to set it to 10 seconds. Caching is a thing, and it's very fast if your repo is small to pull and check if there's a change. But I'm suggesting if you're in production or if you're in a permanent environment, you should not be doing this. You should set up a receiver instead. Okay? And it's part of Flux GA at 2.0. The receiver's been GA since 2.0. We're on 2.6 now. So, or we're about to be on 2.6. By the time you watch this, if it's recorded, you probably can upgrade to Flux 2.6. So how does this work? We had 3 resources we saw. Broadly, there's a subscription between each resource. And these resources have to be in the same namespace. If you have never used image update automation before, this is an important note. If your image resources aren't in the same namespace, they won't talk to each other. Okay? But we have a change that comes from outside of the cluster. The image repository is just a representation of that. So how does this change get in other than by polling? Well, we use a receiver. And on the other end of the receiver, there's a webhook on our image host in this case, right? So for completion, here's the image update automation that goes with those resources. And it's a big resource. It has lots of things you can configure. There's a checkout branch, and it's generating a commit, so that commit has to have an author. It points to a source that that's where your secret comes from. That secret has write access to the repo. So this might be a staging repo. That's how I'm doing this. I have a separate repo for staging because I really don't want to accidentally push a change to production because I pushed to the wrong branch. And I know you can use branch protection for that, but there are lots of things that can go wrong. That's the theme of this talk here. So the message template here that I'm using tells you what files have changed and what objects are changed in those files. This comes from the Flux docs. There's another option down here to create a pull request. So this is my favorite way to use image update automation. I don't want changes to go out to any environment automatically just because they're published. I want to merge a pull request. So this will create a pull request that targets the main branch. Again, that's the main branch in my staging repo. That's just another clone of production with some changes and a different environment that's hosted from it. But we can merge back and forth between those repos. All right. So outside of the cluster, what does this look like? The image update automation pushes to Git repository host. It pushes a commit to one of these hosts. And they all have basically the same interface from image update automation, push to SSH or HTTP. So this is not very complicated. But what happens then? Well, we'll get to that. So we've got our image host. We've hooked it up to receiver, and it triggers the image repository, which then triggers the image policy, and that triggers image update automation. These are subscriptions, okay? There are other places you can use the receiver. The most common one is to push to the Git repository. So we've got our, and the workflow is probably not as simple as that, right? There's lots of moving parts. We're going to push to Git, and it's going to build an image. That's going to get pushed to the image host. That should trigger a receiver to trigger the image repository and so on, which is going to push another event to the Git host. Hopefully that doesn't trigger another build. And your Git host should also be hooked up to a receiver that reconciles the Git repository that then is in turn subscribed to by the customization, which does the apply to Kubernetes. So if you're new to Flux, these are the resources that Flux has under the hood doing the heavy lifting for you, okay? And here's another way this can work. If you're using Helm chart, right, there's something that applies the Helm release to the cluster. The Helm release has another source, the Helm chart, which comes from a Helm repository or an OCI repository. We're not going to get into that today, but just so you understand, anything that's a source, right? Okay, so there's two types of resources in Flux. There's the type that connects to something outside, Git repository, Helm repository. We'll call them sources, but we're kind of glossing over a little bit here because not all of these are in the source API. Image repository is kind of like a source, but it doesn't contain an artifact, so it's not really a source. But we'll call them sources. So these are resources that are physically hosted outside of Kubernetes. So the automatic subscription is not really possible. We can't auto-negotiate that subscription. But inside the cluster, we can. And actually, there are solutions that do GitLab has GitLab Agent. So if you have GitLab and you are able to use GitLab Agent, go get a soda. You don't have to watch the rest of the talk because receivers are not necessary for you. You can just install a GitLab agent and it's going to do the same work as a receiver. Every single command. Okay, so you just Helm install GitLab agent, and that's basically all you need to do, point it at your GitLab instance. But frankly, most of us are still on GitHub, I think. I'm on GitLab, and I actually couldn't get this working. We've had a GitLab instance for a long time. There's something wrong with my ELB. It doesn't support the WebSocket connection upgrade, so I'm not sure what to do about that, other than to use the native Flux solutions and to enable receivers, which works great, even on GitLab. I'm going to try to pick up the pace here because, as you can see, Flagger's gotten a little bit ahead of us, and we're running out of time. But we have a few minutes extra, I think. So, okay, so there's different types of receivers. I'm not going to get into that. You can follow the docs, but for better security, you want to validate the push that it actually comes from a valid source. So what do I mean by security? I mean, we don't want a denial of service attack. There's not much that can go wrong when someone can just tell you to reconcile now, because the payload isn't really significant. It just, in most cases, it's just going to trigger a reconcile. There's not like they can send instructions to your cluster through the receiver. So it's very safe to do this, to enable. All right, so there's two types of resources, like I said, sources broadly and appliers that transact artifacts between them, okay? Appliers can automatically subscribe to their source, and this is supported by Kubernetes. All right. And then there are resources with no reconciler, okay? Alert, image policy. Actually, in Flux 2.6, image policy is going to add a reconciler. So happy news. We can now use the latest tag again. It's come full circle. I hope everyone gets a laugh out of that. Okay. So now image policy will indeed have a reconciler, but alert is still not reconciled, but most Flux resources are reconciled on an interval, okay? So if we're setting up receivers and subscriptions are automatic, why don't we just, set this interval to a very long number? What could possibly go wrong? And that's actually the meat of this talk. In the last few minutes, we're going to cover how do receivers actually work in some detail, okay? Receivers can be connected to any of these sources and many others. I'll call attention to the generic stuff up here. If your Git source or image source isn't on the list, you probably can still use the generic webhook, most likely. All right, what does a receiver actually look like? It looks like this. See, there's an interval there as well. This one is pointed at GitLab, and it listens for certain events. We see some of these types can filter based on the event type. Some of them can't. That's what's in the payload. It's going to tell you what is the event type. So if we're not interested in ping events, I don't know, there's different types of events that we might want to skip. This is a filter, okay? So, and what does that interval actually do? It's reconciling the receiver with its secret ref, if you notice the secret ref that was in there. So what is the secret for? Again, we want to authenticate the push to make sure that it actually comes from a verified source. This is for security, okay? So the secret, your remote should have the secret. It should be able to prove that it has the secret cryptographically using an HMAC signature. And we generate this hook URL based on the secret. It's a hash. So this should be stable depending on your secret. So if your secret is rotated, the reconcile is eventually going to come along and it's going to update the hook URL. So what can go wrong, right? What could actually go wrong here? Well, the secret might not match. You might have rotated the secret in one place and not in the other. You might have failed to configure the webhook completely, or someone might have gone in there and deleted it. Lots of things can go wrong here, okay? So pro tip, use infrastructure as code to build receivers and webhooks, to build this link so that you get a repeatable experience. All right, so what else can go wrong, right? Well, if you're using external secrets, I'll tell you one thing that I had go wrong. Somewhere along the line, something adds or removes a new line at the end of my secret, and that actually changes the hook URL. So use infrastructure as code everywhere you can to support this, but also use external secrets so you can rotate your secret programmatically, so for compliance needs and security, right? This is a great combination. This is what I'm using at my work. And for compliance purposes, this is a must. Anything that's a secret needs to be rotated, okay? So another note about receivers and about Flux Reconcile. How do you know what to reconcile? Well, hopefully by now it's clear. You should reconcile the source because everything downstream of the source is subscribed. So if there's a change in the source, the Git repository changes, the OCI repository changes, then downstream, the customization is going to update automatically. There's not going to be a delay because of the subscription. Those delays are bad, okay? But I use ChatGPT to help me build some of the content for this talk. And no, there's no race condition, no non-deterministic behavior, but we want the apply to happen in the right order because otherwise there could be some waste and something surprising might happen if our customization reconciles before the source. We certainly won't get the behavior that we want. So set up receivers, use event-driven reconciliation. What else can go wrong? Well, there's a whole list of things we haven't mentioned that can go wrong, right? User error is obviously the most common type of error, and that's why we need to be able to iterate quickly because we want to correct our error and move on quickly so we don't have to so no one sees that we made a mistake, or maybe someone will see if they read the Git history, but it shouldn't affect production for any longer than it needs to. And if these things are all in staging environment, it won't affect production at all. So again, strongly recommend a staging environment, a dev environment, and I recommend you use all these same techniques in those environments as well, if you can. If it's a permanent environment, you should support it this way so that the developers get a good experience at every stage. So how do you test for the failure conditions that we've talked about? Well, you can send a post to the receiver, and you can mimic the payload. If it's depending on what type of receiver it is, you can probably generate a post that will actually trigger the receiver on an interval and monitor the return. But aren't we just pulling again with way more steps if we do that? Yeah, well, kind of. But what if you're the dev here? You want to monitor everything. If you're building a system that doesn't have monitoring in place, that's where it's going to fail, I think, every time. Okay, so probe your receiver endpoint periodically. You don't have to go to all that trouble. You can just hit the hook URL with a GET request, and if you get a 400 back, that's good news. That doesn't cover every failure mode, but it will probably catch most of the failure modes that you need to worry about, right? And again, most of the failures aren't misconfigurations. There certainly are a lot of ways you can misconfigure things, but most of the failures are a user error. Right? We forgot to commit the file that we changed or something else. Right? The change is wrong. It has an error in it. It was rejected. So we'll see that in the notification. We can go back and fix it and then move on quickly. All right. So what if I'm the only dev? Yes, definitely monitor everything, especially then, because you probably have a lot on your plate. It could be days until you notice the receiver's broken. You might not be working on every Git repo. You probably have more than one Git repo if you're following the advice from Chansu and Corey's talk. Don't be, I don't remember which virtue this is, but gluttony, right? If you have a mono repo, you're probably doing something wrong. So who knows if you'll remember what you changed? So shorten feedback loops. Do this to avoid burnout. All right. What else can go wrong? Your notifications might actually not be firing. That's another failure mode that's kind of a pain to detect. How do you know who's going to tell you when your notifications are failing to fire? How do you know? Well, you can curate and use a secondary system. That's one way you can tail logs. CloudWatch has log monitors. So if you're in AWS, you have access to this. You can monitor for the condition in the logs that the notifications aren't going out. It's clear as a bell whether they're working or not from the notification controller logs. What else can go wrong? Well, I'm using EKS auto mode, and that has Carpenter, and it's deleting nodes every day, and my notifications are a mess. I have no idea if things are right or wrong because there's always an error in there when I wake up. How do I know that this is not a problem that I need to investigate? And we really don't have enough time to cover this in detail, but I'll give you a tip how I solved the problem. Carpenter, like most Kubernetes tools, generates Kubernetes events, and you can monitor those events. How do you monitor those events? That is an open question that I'm not sure how to suggest you solve it. I know there are tools for monitoring generic events, but I didn't want to add another tool in this economy. So what I did instead is I built something called Flux Event Relay. It uses the Flux events package to trigger notification controller to send these events out the Flux way, right? Okay, so I built this. It's not published yet, but if people care about this, if this is a common problem, I will definitely find a way to publish this and share it with everyone. I hope that you've enjoyed my talk today. If there are questions, I'm happy to take questions in the 2 minutes that we have left. Let me check in with the questions. Let's see. Definitely join our community if you're interested. We have Flux Bug Scrub, where you can meet me and ask me questions directly. This is a weekly meeting that I manage myself. Sometimes I'm not there. If you don't see me, send me a message on Slack. I'm very happy to answer questions or help you with your GitOps problems. And also join us in the Flux channel on the CNCF Slack, or find me on Kubernetes Slack or any of the other places where I am. Very happy to meet people who are GitOps practitioners anytime.
Kingdon, do you think you have? Thanks so much. Do you think you have a minute or so to reply to one of the Q&A questions?
Yeah, I'm looking. I'm going to go through these questions and see. I see there are a couple of questions.
Well, we can also do we can do that async.
Yeah, I think I'm going to do it async because I don't want to hold up the next presenter. But I really appreciate you, Scott, for helping us be here today, and all the organizers. Thank you, and pleasure to be here.
Thanks, Kingdon. That was great.